Question 1. Right, if the diameter is 26, what does that mean the radius has to be? Half of that, or 13. Good. Okay, what about question 2? This is one that it might be helpful to draw it. So if you say, name that part of a secant. So if we take our circle and we draw a secant, or a line that passes through in two places, and we find what part of this lies on the circle. So there's only two parts that fall on the circle. And in its interior, so here's the interior. So what would this be called? Chord. Good. Okay, so a chord. Okay, name a line that intersects the circle at exactly one point. This, by definition, is tangent. The next example. So assume you have a circle with a diameter of 10 millimeters. If point P falls outside of this, in the exterior of this, or I'm sorry, falls 6 units from this, is it in the exterior or the interior? So I kind of answered that as I described it. But if the diameter is 10, that means the radius is 5. So any point that's 6 units away is going to be in the exterior. What about the next question? Point M is located in the exterior of a circle. So this circle has a radius of 29, and point M is located somewhere in the exterior. A distance of 8h minus 3 units from the center. Okay, so what relationship or what restriction is going to be applied to that? That expression has to be greater than 29. It can't equal it, or else it would fall on the circle. It can't be less than it, or it would be in the interior. So if we solved for this, adding a 3 to each side, we get divide by 8. We have h is greater than 4. So that would be our restriction. And then finally, if you have the ratio between the diameters of two circles is 3 to 2. So let's say we have 3 times some multiplier n, another one 2 times some multiplier n. What's the ratio of their circumferences? So you could, if you wanted to, you could go through and figure out, well, if the diameter is 3, that means the circumference is going to be d pi, so d, or 3n pi. Here the circumference is going to be 2n pi. And so if you relate these, 3n pi over 2n pi, pi's and the n's cancel, and you get this same ratio. And in fact, what you're going to see as we start to get into these enclosed figures is anytime you're dealing with similar figures, right? And similar figures mean figures that you could enlarge or reduce, but map directly on top of each other. So if you enlarged one or reduced one, would it superimpose directly on top of the other? Well, that is true for all pairs of circles. All circles are similar to one another. They have that property. And anytime you have similar figures, the ratio of their corresponding parts, which you'll see me represent with a lowercase p and then a little arrow to one direction or to the right, those parts are always going to have the same ratio. And so what that means is if you have two circles and their diameters have a ratio of 3 to 2, what are their radii going to have a ratio of? 3 to 2. Any one-dimensional measurement will have that same ratio, 3 to 2. So their circumference is a ratio of 3 to 2. If you had corresponding chords between these two circles, so let's say this chord and this chord corresponded. They were located in the exact same spot so that if you reduced or enlarged one, it would map directly onto the other. Those would also have a ratio of 3 to 2.